This is Math Connection A, factors that affect solubility. Remember, this is in the above and beyond section, so if it gets to being too much and you need to shut it down, that's fine. This assignment is optional. All right, effect of temperature on solubility. So let's take a look at all these crazy lines. This is actually designed to look at one line at a time. So you're not trying to figure out what all the lines are doing. It'll just have you look at one substance so you find the one substance and see how it does. So like table salt is right here. So if we need something about table salt, we're just going to look at this line that's associated with table salt. If it is sugar, glucose, we're going to look at just this line that's associated with glucose. So it looks kind of complex, but it's really not too bad. Okay, so this title, effective temperature on the solubility of a solid. So how heating something up makes it easier or harder to dissolve something. So when you make sweet tea, you dissolve the sugar while the water's still hot, and that's how come you're able to get the sweet tea so much sweeter than you can at the table if they don't have sweet tea at the restaurant. Okay, this one over here is the effective temperature on the solubility of gases. So this is like bubbles in a Coke. How do you make a more bubbly Coke? How do you make a less bubbly Coke? Okay, and again, you're not looking at all of these at once. You're just looking at one line at a time. So if you're looking at just oxygen, you're looking at just this line. Just nitrogen, just this line. So I know you can't really see the colors on that, but you should be able to see the colors on your screen, and they go in order. So whatever's the top ones here is top here and bottom here, bottom here. All right, let's take a look at the questions, see if we can figure out what these are saying. The graph on the left, so the solid dissolved in a liquid, shows the effect temperature has on the solubility of several solids. Write a general rule to describe the graph above. For most solids, as the temperature of the solution blank, the solubility will also blank. So it looks like for the most part, when you look at temperature, it is going up. So I'm going to say the temperature of the solution increases. It's not perfect. This one goes down, but all the rest of them go up. So I'm going to say it increases. The solubility will also increase. So the solubility is over here, the temperature's here. So if you do them both, you make them both higher, they both go up. So increase and increase, a direct relationship. Number 2, what do you notice about the effective temperature on the solubility of NaCl? Okay, so we're looking at just NaCl, and it looks like it's a pretty flat line going across. So I'm going to say the effect of temperature on solubility doesn't change much. Doesn't change much. And this is just for NaCl, not for the rest of them. It changes a lot on a lot of the rest of them. Does the rule you constructed above apply to every solid? No, it does not apply to this bottom one. So, no. Okay, and number 3, on the graph on the right, so the one with the gases, shows the effect temperature has on the solubility of several gases. Write a general rule to describe the graph above. Does the rule apply to all gases shown in the graph? For all gases, the temperature of the solution, okay, so the temperature of the solution, we're going across 10, 20, 30, 40, so that's getting bigger. So that definitely increases. The solubility goes down, so it decreases. So this is an inverse relationship. As one goes up, the other goes down. Does this rule apply to all of the gases in the graph? Yes, they all show the same pattern. Some of them are steeper than others, but they're all following the same pattern. So I would say yes. Okay, and that completes this assignment. Have a great day.